Hello, discrete math fans. We've already talked about how to check to see if a relation is transitive. Now I'd like to talk about a concept called the transitive closure of a relation. A relation fails to be transitive when it fails to contain certain ordered pairs. So if you have a relation that contains 2, 7, and 7, 4, then the ordered pair 2, 4 has to be in the relation, otherwise it's not transitive. Let's describe an operation where we're going to take a non-transitive relation and add ordered pairs until it is transitive. But I'd like to just add as few ordered pairs as possible. As a loose definition, we're going to say that the relation that's obtained by adding the fewest numbers of ordered pairs to the relation that would ensure that it's transitive is called the transitive closure of the relation. A more precise definition would be to say that the transitive closure of a relation is the smallest transitive relation that contains R. Let's give a precise definition. Let's say that A is a set and R is a relation on A. We'll say that the transitive closure of R is the relation, and we're going to use this notation, R with a superscript T. That's the relation that satisfies these properties. So first of all, it has to be transitive. It has to contain the original relation. And if S is any other transitive relation that contains R, then our thing that we want to call the transitive closure has to be a subset of S. Now, if we happen to start with a finite relation, we can always get the transitive closure by executing this algorithm. So here's some pseudocode. So while the relation is not transitive, find A, B, and C in the set A where the ordered pairs A, B, and B, C are in the relation, but A is not related to C. And since we need A, C to be in the relation, we'll just add it to the relation. And keep doing this until you get to the point where the relation is transitive. This algorithm is guaranteed to terminate. When it does, the final value of R will be the transitive closure of the original relation. This is not a very fast algorithm, but it's guaranteed to work. If the relation is infinite, we'll have to do a lot more thinking, because then this relation is not guaranteed to terminate. I'm not going to prove any of these facts. The fact that it's guaranteed to terminate and is guaranteed to give you the transitive relation. I think I'll just leave it at that. Okay, that's all for now.